The next thing that we discussed, moving through the annex, was Kirchhoff's laws. There was Kirchhoff's voltage law. And where did we apply this? What type of circuits? Series circuits. There was Kirchhoff's current law. Where did we apply that? In parallel circuits. Okay, very good. So, we can write up a series circuit to start with. Okay, so here we see the arrangement for a basic series circuit. Which direction is current going?
Counterclockwise.
Counterclockwise, correct. Current's going counterclockwise. I can now put in my polarities, yes? Okay, so we go negative to positive. Now, what do we know about resistance in series? It's additive, so we can find the total resistance? 10K. We'll take 4K plus 3K plus 3K equals 10K. Can we find the total current? Say that I sub t is equal to E sub s over R sub t, or the source voltage divided by the total current, which would be 10 volts divided by 10 k ohms, which is equal to 1 milliamp. All right. What do we know about current in series? It's common. So that 1 milliamp is going to hit every resistor there, yes? Well, 1 milliamp across a 4 k ohm resistor would give us what kind of voltage drop? 4 volts. So VR3 equals 4 volts. What about across a 3 k ohm resistor? 3 volts. Okay. VR2, 3 volts. And then the same for VR1. Okay. Well, at this point, we've solved for pretty much all of the electrical parameters that would be called for, with some few exceptions. For instance, if I were to say, find the voltage of V sub C, what voltage would I be looking for?
C direct.
C to reference, or to the negative terminal, right? Okay. So in that case, what would I do? I would start at C, and then what? Go to the node. After the node, where do I go? Down. So what do I pick up? Positive 4 volts, and there's the negative terminal. So that voltage, V sub C, would be what? 4 volts. Okay. How about the voltage V sub C, voltage V sub BC? What would that equal? Where would I start? Start at B, I go to the node, down, positive, 3 volts, node C. So that'd be at 3 volts. Can I go the other way? Okay. B node negative 3 node around positive 10. What am I at now? Positive 7?
Positive.
Okay. Negative 4. Now I'm at positive 3. Node, and then there's C. So it works both ways. Okay. Let's get a curveball here. Let's get a curveball here. The resistor R2 opens up. What happens to total voltage? Increase or decrease? Increase to what? Across R2, right? Because we go in series, we go to source at the point of an open. Okay, what about total resistance? It increases. I'm not going to say infinite, we're just going to say it increases. Okay? And what about total current? Decreases to 0. All right. So let's look at voltage sub AB. What is that going to be? What's the voltage A to B? R2 open, what is it? 0 volts? Okay, why? There's no current, right? This is open, means no current flow. If there's no current flow, then the voltage from A to B will be 0. Because Ohm's law tells us E equals I times R, V equals I times R. And if I is 0, then V will be 0. Everyone follow? Okay. How about fill this up first? That's 0. The voltage C to B, did it increase, decrease, or stay the same? What's that? Increased. Why? The current across an open? You're feeling source voltage. Well, let's look at it. Let's go C to B. We go out of C, we hit the node. Which way? Which way do you want to go? Up. There's an open. Can't go any further. Let's go down. Okay, did we hit any voltage here? What did we hit? What? 4 volts. 4 volts? Is it 4 volts still? This is open, no current. 0 volts, right? Down to the node. Across, up, what do we get? Negative 10, over. Do we hit any voltage here? No. Up, node, there's B. So what are we sitting at? Negative 10. Did it increase or decrease? It decreased. What were we at before? Positive 3 volts. So the difference of potential there was absolute value, a count of 3 volts. What is it at now? It's at negative 10, but as an absolute value, it would be 10 volts, right? So which is greater? 10 volts. Sure, it happens to be in the negative polarity, but what you can account for is the fact that if you measure the difference between 3 volts, positive or negative, and 10 volts, positive or negative, 10 volts is still greater, yes? Okay, so keep that in mind.